Now this one over here. So first of all, let's get one side to be 0. So the square on this side. So I'm going to keep this on the side because it has positive coefficient. And now I'm going to move this over, become minus 6 times this. So minus 6 times 3x minus 1. And then also move this over, become minus 3. So I get the other side to be 0. Do you think I can use try and error right now? I cannot use try and error over here because you see what happened? They're not exactly the same inside the parenthesis. This is addition and this one here it is subtraction. They're not the same. So what should I do? What would you like to do? Okay. So since I cannot use try and error directly right now, I will expand this. Okay. Multiply out. So expand this, we're going to use the perfect square formula. So over here, this, we're going to use the perfect square formula. So use the perfect square formula. Okay, everyone, tell me what do I get if I expand this perfect square? Someone asked, can you make this to be positive? Actually, that might be something interesting approach. You can make it positive, yeah. So maybe I can make it positive. Later on, I will subtract it back. Yeah, that might work. That's a very interesting approach. I never thought about that before. Okay, so you can make this positive, but when you make this positive, so you're adding 1. So instead of minus 1, when you distribute over here, then you're actually making, you have to subtract back. Okay, subtract back some number. Okay, so that's interesting. Okay, okay. Now over here, so let's expand this using the perfect square formula right now. So expand this, we get square the first, so we got 9x squared, and then adding what? 2 times the first times the last, right? So 2 times 3x times 1 will be 6x. So then we have 6x over here. And the last one always plus, so plus the square of this is this 1. So we expand this, use the perfect square formula. So we get this 3 chains over here. Okay, now for this one over here, right now let's just distribute this. So distribute here, so become minus 18x, and then negative times negative is positive, so adding 6, and then now minus 3 equal to 0. All right. Now after this, you can see that we need is a quadratic equation, right? Now we're going to combine items. So we have 9x squared. So combine item over here. Okay, so you have this 6x minus 18x. So you have minus 12x. And then you have this adding 1, adding 6, and then minus 3. So which is going to be 4. So plus 4 equal to 0. Now we got a simple quadratic equation. Now look at this one over here. This one has 3 terms, x squared, x a number. So what kind of method would you like to factor this? Remember 3 terms in the form x squared, x a number. We have two different ways you can consider, right? So you can consider using try and error, or you can consider perfect square. So does this look like a perfect square to you guys? What do you think? Yes or no? Does it look like a perfect square trinomial to you guys? Do you think it can be factored? Yes.
Yes.
Okay. Yeah. Yes. Okay. Some of you say yes in the chat. Okay. So let's try to use the perfect square factoring. So because I noticed that the first one here it is a square, and I also noticed the last one here is a square. So this kind of hopeful that might be a perfect square. So let's check this out. So we have this. This is square of 3x. This is square of 2, and then we check the middle. So we have 2 times the base of this and the base of that, right? So 2 times 3x times 2. Well, it turned out to be exactly this 12x over here. So indeed, this is a perfect square trinomial. So we can factor that into perfect square. So what perfect square is that one? So we put down this the base and the base, which is 3x here and 2 over here. Now, because in between over here it is, what color should I use? There's too many choice. In between over here it is a minus over here. Okay, this minus over here. So this will be minus. Okay, the same sign as that one. Okay, so you factor this trinomial into perfect square. Okay, because we recognize that it is a perfect square. So that equal to 0. Now, some of you say, can I use try error? You can also use try error. So this method over here, I used perfect square factoring. And the other one over here, I can use try and error factoring. So we can compare them, okay? So you have this sum equation over here. If I somehow don't recognize it's a perfect square and I use try and error, well, what happened? So the 9 over here, I can try 3 times 3, right? And then the 4 over here, I can try 2 times 2. However, because this is minus, right? Because this is subtracting over here, is negative. So yeah, you got it. Okay, so it is. I make both of them negative because I want to sum up the negative. Okay, so and then you can see that if you cross multiply and add, again you sum up to -6 over here. Again, you sum up to -12 in the middle. So that will also work. So you will have this 3x minus 2 two times. However, because 3x minus 2, because these two are the same factor, right? So you will unite them, okay? Unite them and put it as a square, right? So these two are the same. You unite them and put it as square. So you end up with the same equation. Now let's continue. So if we have this square here equal to 0, the only way to make the square here equal to 0 is a base equal to 0. So we'll have this 3x minus 2 equal to 0. And solving for x will be equal to 2 over 3. So, however, we call this repeated, okay? So this one here, it is repeated solution. So why is called a repeated solution? Okay, if you take a look on this side, these two multiply to get 0. It is going to be either this equal to 0 or this equal to 0, right? So again, you get back to the same thing. 3x minus 2 equals 0. However, you see that for this equal to 0, x equal to 2 over 3. For this equal to 0, x equal to 2 over 3. Both of them get the same solution, right? So it's called a repeated solution. So it's a repeated solution over here because the two factor, 3x minus 2, are the same. Okay, so that's why it's repeated. Okay, so you see this quadratic equation over here? It does have two solutions. Okay, however, it is this one here repeated. It's a repeated solution. Okay.